So in this video, we'll discuss uh, two more things. One is graphing power functions with transformations. Another one is graphing for polynomials. Let's begin. First of all, graphing power functions with transformation. As you know, if the power, notice that x cubed, if it is x to the power 5, if it is x to the power 7, any odd power function, the graph is similar, and any even power function, the graph is similar. So how they will look like? First of all, if it is x cube, this is the graph of our x cube graph and cubic function graph, as you know. And then if you think about, let's say, to the power 5 graph will be what? Almost similar. To the power 5 graph is almost similar, just the line will come a bit closer to the y-axis anyway. And x to the power 4 graph is up opening parabola as usual. X to the power x square graph also up opening parabola, just uh, they have the similar shape: x to the power 4, x to the power 2, x to the power 6, x to the power 8, any even number power, they have the similar graph. They have the even if the power is even. Now, how does x cube plus 2 change the graph? So you see, this is x cube, so x cube is here, they are similar, and we have just only plus 2 here. So for that, this x cube graph will move to 2 unit up. The entire graph, the whole graph, this whole graph will move 2 unit up. So the graph should, the center, if you say this is the center, so this will come here. Okay, this will come here. So this will go 2 unit up. And then let's say this x cube plus 2, now it is x plus 1 whole cube plus 2. Now we have another thing here within the bracket, x plus 1 whole cube plus 2. For this plus 1, for this plus 1, extra plus 1, what will happen is, notice that this is plus 1, so the graph should move to the left side 1 unit, because in our original formula, x minus h whole square plus k, which is in the shape of our shape of the quadratic function in the vertex form, but it is not quadratic. That's true, but the shape, look at the shape of the graph, it still gives us the similar sense. So for this plus 1, then the graph will move to the left side 1 unit. So the entire thing, the whole graph, the everything will move at a time. Then minus x to the power 4 graph will be what? Notice this is the plus x to the power 4 graph. Then if it is minus x to the power 4, it will just have some reflection about the x-axis. So flips down the graph upside down, so it will become upside down. Then if we have minus to the power 4, x minus to the power 4 minus 1. So see, this is minus 2. That means now it will go for this minus 2. Now the graph will go right to the right 2 unit, and then for this extra plus 1, for this plus minus 1, graph will come down 1 unit. That means once again, for this minus 2, graph will go to the plus 2, and for this minus 1, graph will come down 1 unit. That means graph should come here, then come down to this point. That means the graph will be like this here. Okay, let's check. So this should be the graph of this one. And then we have this is in plus practice, fx equals to x minus 1 to the power 5 plus 2, then x plus 2, x plus 1 to the power 4 plus 1. So see, this one is actually a cubic function similar graph. For this 2, graph will go 2 unit up. For this minus 1, graph will go 1 unit to the right side. So this should happen. And if you want to know the value of the x-intercept and y-intercept, of course we have to know to find out the y-intercept, we have to put x equals to 0, then minus 1 to the power 5 plus 2, that means y-intercept will be plus 1. Then to find the x-intercept, we have to put y equal to 0, that means if x equals to 0 if we put, then we have to send this 2 to the other side. Then for this 5, we have to give here fifth root, then x plus fifth root of 2 plus 1, whatever it comes, answer will be here. I mean that value is here, fifth root, and this is the 1. This is the y-intercept 1. It looks like 1 is here, 2 is here, 3 is here, 4 is here, but you will notice this is 4. That means 1 is here in the middle. So this is the transformation. And as I said, this for this plus 2 graph will go to the 2, and for this minus 1 graph will come to the plus 1. So this is plus 1 and then other things. For this one, what will happen is x plus 1 to the power 4, that means it is a even power function. And then for this plus 2, for this plus 1, first it graph goes to the graph will uh, go to the 1 unit left side, and then for this plus 1 graph will go 1 unit upside, and for this 2 extra 2 graph will come a little bit closer to each other. The two head will, or the graph will grow faster, if you want to say. Okay, let's check. So this is the final graph. This is the final graph. So graph 1 unit up, then 1 unit to the left side. Then for this extra 2 we have adjusted the value. Now one thing here, very interesting here, you will see if I put here 0, what happens here? If I put here 0, then 0 plus 1 to the power 4. 0 plus 1 to the power 4 means 1 to the power 4. 1 to the power 4 means 1. 1 into 2 equals to 2. 2 plus 1 equals to 3. That means our this point will be at 3. So if you have this point, then this point's exact same point will come here. So this is another way to validate your graph, to make the graph, when you draw it, to make the graph more or less accurate. Okay, this is another way to think about it. Now, analyzing the graph of a polynomial functions, we will be using all these steps, step 1, 2, 3, 4, 5, 6. We will be using all these steps to analyze the graph of polynomial functions. So we will discuss these steps with some real example like this one. So let's look at this one. Consider the graph of fx equals to blah blah blah. So it looks like tons of things here. See, this is actually x. So x minus 0.1 x, then x plus 2 cube, then x plus x minus 3 to the power 4. So what's going on here? If you look, we have x, then x to the power 3, x to the power 4. So how many x here actually? 4, then 3, 4 and 3, we have 7 plus 1 equals to 7 plus 1 equals to 8. Total 8. That means x to the power 8 we have maximum, or the degree of this function is x to the power 8. Then we have a minus here. So what does it mean? Minus x to the power 4. Notice that we know x to the power 8. If it is plus x to the power 8, then the graph will be like up opening parabola. As it is down opening graph, so graph will be a down opening parabola. So and what are the real 0 here? So you see, if I put x equals to 0 here, then the whole function becomes 0. That means at x equals to 0, the whole function becomes 0. So x equals to 0 is a real 0. Then if I put x equals to minus 2 here, then the whole function becomes 0, because see, minus 2 plus 2 equal to 0. So 0, this is all multiply, 0 into 0, whatever, 0 into anything equal to 0. So whole function becomes 0. So at x equals to 0, my whole function becomes 0. At x equals to minus 2, my whole function becomes 0. And at x equals to plus 3, for this term, plus 3 will come, the whole function becomes 0. Now, near each real 0, how the graph will behave, first of all. To know it, we have 3 real 0 here. One is x equals to 0, another one is x equals to minus 2, another one is x equals to plus 3. So first of all, we will put x equals to 0, not here, because we have found x equals to 0 from this term. So we will put it here, and then we will do the calculation. From the calculation, we will have some idea what type of behavior we will see from the x equals to 0. So if you do the calculation, first calculation is near x equals to minus 2. If you put x equals to minus 2 here, but not here, we cannot put it here. We have to put in some other 2 place. So you see, after the calculation, it comes 12.5 x plus 2 cube. So this is what? This is some kind of cubic function at x equals to minus 2. Some cubic function, see, x cube, 12.5 x cube. So that means at x equals to minus 2, it will be a cubic function. And notice this is actually a cubic function. This is minus 2. This one is minus 2. And here, it is a cubic function. You remember, you know the graph of x cube. This is the x cube graph. So near x equals to minus 2, the graph will be like this. Then what this one? Then what will be near 0? So if we put 0 here, we cannot put here, we have to put here and here. Then you see we have minus 6.48x. So you see y equal to minus x. This number actually represents the steepness of the graph, and this represents the negative x. Negative x graph is like this, like this. Y equal to negative x graph is like this, and y equal to positive x graph is like this, as you know. So that means we have this here. So this one, this line, is the um, behavior near x equals to 0. And for near x equals to 3, you see this is what? This is a parabola, x to the power 4. It is a parabola. And for minus, this is a down opening. And you can see this shape is a parabola, down opening parabola, which is this shape. And then our final graph. So if you combine all of them, also, as we said, as our total power, maximum degree of this question is x to the power 8 minus x to the power 8. So it is a down opening parabola. That means, let me draw it here. So our final graph is a down opening parabola. This is a down opening parabola. If you just ignore all of them, if you ignore all of them in the middle, then it is actually a down opening parabola, which is, of course, this is coming from our the degree or the end behavior, if you notice, and from the end behavior. So this is how we understand. This is how we understand how the graphs. We will go to the next slide and you will see it. This is how we understand the behavior of the graphs, the shape of the graphs. We can estimate them. Then go to the. So these are the pretty much the same things that 6 steps we said in other page. This is some recap, because the same kind of idea we will be using here. Use this graph to use this idea, these things, these concepts, or these steps to graph it. So here we have x, then x minus 3 whole squared. That means what is the maximum power here? X squared and 3, that means x cubed. So minus x cubed. So minus x cubed graph will be our the final behavior, and then real 0 is at x equals to what? X equals to 0 and x equals to plus 3. Then similar calculation we have to do. So this is the end behavior. This graph is for the end behavior, because x to the power minus x cube. For minus x cube graph is this. Minus x cube graph is this. This will be the minus x cube graph. Then x-intercept. So you see we have x-intercept at x equals to 0 and x equals to plus 3, and y-intercept is 0. How do we know that y-intercept 0? Because if we put x equals to 0, our whole function becomes 0. And then multiplicity, as you know, the multiplicity of x is 1, multiplicity of this is 2, so we have the multiplicity also. Whether it will cross or touch, how do we know? See, here the power is 2, so it will just touch, and here the power is 1, so it will cross. So at x equals to 0, the graph will cross, and then at x equals to plus 3, the graph will touch. How many turning point and how many degree? As see, maximum degree is what the degree of this function is what? The degree of this function is 2, then 1. So total degree is 3. So as the degree is 3, so maximum 2 turning point. Degree always maximum number of turning points are always 1 less than the degree of the given function. So near 0, the function becomes this. Near 3, just by putting it here, we get this value. So you see, first of all, near 0, it becomes like some straight line with negative slope. This is a negative slope straight line, and this is a even power function with a reflection, minus 3x minus 3 whole square, even power function with a reflection. So if you combine them, then actually you will get the graph. By combining both of them, we get the graph. So first of all, this is the up opening. This is our arrow sign, our end behavior. Then this is our x equals to 0. This is our x equals to 3. So at this 2 point, we have the real 0. And see, this one is a parabola, down opening parabola. This is a negative gradient or negative slope straight line. So basically, now you can say, sir, how do I know that the graph will turn here? This is pretty much this is not so easy. Where the graph will start. Suppose the graph is coming, or you know that the graph will be like this. But how do you know that this graph will start turning here? This is the exact shape of the graph. So for this, the method is, one method is usually we do approximation, uh, but actual exact method, correct method is we have to put some value here in the function and then check where, what happens. Suppose in this point, what happens if we have this point and this point, then we can close it as much as possible. So this is how we can understand. And also you can see the maximum number of turning point, one here and one here. So we have two turning points here. In this graph, I think this is one of the very interesting graphs in our entire chapter, by which we can actually test all the concepts, or maximum number of concepts, if you understood this or not. So this is our question, and the question is, this is a given function, and for this given function, there are four given options, 1, 2, 3, 4, and the question is which one is the correct graph of the given function. This is the question. Think about it. What can be the answer? First of all, notice that this y-intercept is -6. Okay, y-intercept is negative. How do we know? If you put x equals to 0, then all of this term will become 0, and only we have the -6. So -6 is, see, this one, and this one look like they have the -6. This is negative because this is positive. See, this is positive. So as this is positive, so already this is out of our consideration. Then look at this one. What happens with, so see, what is this? This one is what? X to the power 4. So as you know, if it is x to the power 4, how many number of turning points we will have? 3, right? If the power is 4, then the turning is 3. So how many turning here? 1, 2, 3. This is correct. 1, 2, 3, 4, 5. So this is 5. This is not correct, because our turning will be maximum 3 turning, and this is 1, 2, 3, 3 turning. So answer may be B number or D number. Okay. Now let's look at the other thing. What is the end behavior? Now you see the end behavior will be, this is x to the power 4 graph, right? X to the power 4 graph means up opening parabola. Up opening parabola. So this one, see, this one look like up opening parabola because this is a down opening. This says down, down. So this one is our answer. Okay, because this is a down opening parabola, so this is not answer. That means this is our answer for this question. So this is how we analyze the graph of polynomial functions, and this is a pretty much interesting and very, very useful tools for understanding the maths. Okay, so that's all about this class, and we have some works here. This is actually one class. This is another class. Total 2 class works here. So this will be your homework or practice work. Actually, this should be, you should practice all of this maths. It covers a lot. These numbers are from the book, not from the worksheet, because worksheet is, numbers are different. Okay, in the book they will match with the book, or we can try to match it with the worksheet. Anyway, thank you all. Thank you very much. I hope somehow it works. Bye bye.